download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about redox reactions. Now we have previously learnt the terms oxidation and reduction. And we have learnt that oxidation can mean the addition of oxygen, and that reduction can be the removal of oxygen. But oxidation and reduction can also be used in terms of electrons. Okay, so a loss of electrons, so if an atom loses electrons, so a loss of electrons is equal to oxidation. So when we talk about oxidation in terms of electrons, we're talking about a loss of electrons. Whereas a gain of electrons is reduction. Now a good way to remember this is by the mnemonic oil rig, okay, which stands for oxidation is loss, which is oil, O-I-L, and reduction is gain, which is R-I-G. So oil rig, okay. Oxidation is loss, reduction is gain of electrons. Now when reduction and oxidation happen at the same time, so when reduction and oxidation happen at the same time, it's called a redox reaction. You see here we're taking the red from the reduction and the ox from the oxidation. It's called a redox reaction. Okay, so just to quickly summarize that, oxidation is the loss of electrons when we're talking about it in terms of electrons, and reduction is gain of electrons. When this happens at the same time in a chemical reaction, we call the reaction a redox reaction. Now displacement reactions are examples of redox reactions. Now you'll remember a displacement reaction is when a more reactive element displaces or takes the place of a less reactive element. Okay, so to help us out with my explanation here, I've written to the side the reactivity series. And remember at the top, we've got the more reactive elements. And as we go down, we get less reactive until we get the least reactive element. And this is the reactivity series. So if you haven't watched that video, then please go and watch it. Okay, so one example of a displacement reaction is when we react magnesium with sulfuric acid, and that produces magnesium sulfate plus hydrogen. Okay, so I'm going to write the symbol equation to this to help me explain what's going on. So magnesium is of course magnesium, it's a solid, Mg, plus sulfuric acid, which is H2SO4, goes to magnesium sulfate, Mg, SO4, plus hydrogen, H2. Now we can see from this reaction that what has happened is that the magnesium has taken the place or displaced hydrogen in sulfuric acid because it's more reactive. So if we look at our reactivity series, magnesium is higher than hydrogen, therefore magnesium is more reactive, therefore it's going to displace the hydrogen from the sulfuric acid. So if we look at that in terms of what's actually going on, we've got magnesium here, plus, and here we're going to have our beaker, which is going to contain our sulfuric acid. Okay, so we've got the SO4 2 minus ions and the 2 H plus ions. And that means that the magnesium, okay, the magnesium has displaced the hydrogen ions to bond with the sulfate, and the hydrogen atoms have now left the beaker as a gas. So the key point to take away from this is that the magnesium displaces the hydrogen ions from the sulfuric acid because magnesium is more reactive than hydrogen. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers and so much more. The link is in the description. So here again I've written the symbol equation for that reaction, and again I'm going to draw what's happened. So we got the magnesium atom here, and that's been added to our sulfuric acid, which remember contains 2 hydrogen ions, and our sulfate ion, okay, and that has become magnesium sulfate, which is now magnesium ion, so 2+, and our sulfate ion 2- plus our 2 hydrogens. Okay, so what we can see here is again that magnesium has taken the place of the hydrogen because it's more reactive than hydrogen. And what's happened is that magnesium atom has become a magnesium ion. It's become 2+, and therefore magnesium has lost 2 electrons. Whereas hydrogen, our H+ ions, they were ions. Okay, they were ions and they've become atoms. So they gained electrons. So they were H+ ions, now they've gained electrons to make them atoms. And if we can see here that our sulfate ion has not changed. So we call this a spectator ion. Okay, because it spectates the reaction, it does not change. They're of no interest really. They've not changed. So they're here at the reactant side, they're a sulfate ion, and here at the product side, they're also a sulfate ion. Now from this we can write an ionic equation where we only write the ions that were involved. Okay, so if you see here, we've got our magnesium. So that's the magnesium. And here we've added it to our 2H+. And then here we've added it to our sulfate ion. And then over on this side, we've now got a magnesium ion plus our hydrogen atoms, which are no longer an ion, plus our sulfate. Okay, now because our sulfate ion was a spectator ion, they cancel each other out on both sides, so we do not write them, okay, because it's a spectator ion, so we do not include them in our ionic equation. Okay, so what our ionic equation actually should look like is Mg plus 2H+, and that produces Mg2+ plus H2. So you can see here that it's only included the ions that were involved in the reaction and has not included the spectator ion. And we call this an ionic equation as it only includes the ions involved. Now we can also write half equations for each of these 2 ions and atoms individually. Okay, so for example, if we wrote magnesium, then what's happened to magnesium is that it has formed a magnesium ion, and because it's formed an ion, it is therefore lost 2 electrons, so it's also formed 2 electrons as well. Okay, so that is our half equation for magnesium. And now if we can write a half equation for hydrogen, okay, so it started off at 2 H plus ions. That's now been given, and that's now added 2 electrons, which have come from the magnesium, to now form our hydrogen atoms, or our hydrogen gas. Now, because, if you remember going back to what we were talking about earlier, because our magnesium has lost 2 electrons, we can call it an oxidation reaction. And because our hydrogen has gained 2 electrons, it is a reduction reaction. So here you can see that our displacement reactions are examples of redox reactions, because there is oxidation, i.e. loss of electrons, and reduction, there is gain of electrons. Okay, so what we've written here is I've shown you what's happened in terms of the ions. Then I've written the Ionic Equation, which, remember, only shows the ions involved. It does not account for the spectator ions. And then I've broken that down in further into the 2 half equations for this reaction. So here I'm going to try and actually show you what's happening in this reaction. So I've drawn our beaker, and we've got our sulfate ions and our hydrogen ions, so our sulfuric acid, and we've added magnesium. And I've drawn the electronic configuration for magnesium with 2 electrons in the first shell, 8 electrons in the second shell, and then 2 electrons in the outer shell. Okay, so here is what's actually happening. So this, because magnesium is more reactive than the hydrogen, it's going to take the place of the hydrogen to bond with the sulfate ion. So what happens is the magnesium gives its 2 electrons to the H plus ions. Okay, now what happens is magnesium gives 1 electron to this H plus ion and its other electron to this H plus ion. Okay, so the magnesium loses 2 electrons, and therefore, as we said in the previous slide, that this was oxidation. And what's happened is the hydrogen ions, the 2 hydrogen ions, have gained 1 electron each, and therefore they have been reduced. So that is a reduction. So what that then forms is a magnesium ion, as it's lost 2 electrons. Okay, so the first shell would now contain 2, and the final shell would contain 8, as it's lost the 2 electrons in its outer shell, and this would now be a 2 plus ion. And those electrons have gone to the hydrogen to form hydrogen atoms. Now remember, a hydrogen atom only has 1 electron, so these have their 1 electron that they've got from the magnesium. And of course, the sulfate ion has not changed in this reaction, therefore it is a spectator ion. Okay, so the magnesium loses 2 electrons to form a magnesium 2 plus ion, so it's a positive ion, so we can call it a cation. And the 2 hydrogen ions form H atoms. Okay, so they form H atoms. And the sulfate ion, and again is spectating, so we call it a spectator ion. Okay, a spectator ion. And then what will happen is, because our hydrogen is a gas, it will then escape as H2 as a gas. So 2 hydrogen ions then form. Okay, so this hydrogen ion will then form a bond with this hydrogen ion to form H2. So 2 hydrogen atoms will form a covalent bond, i.e. where they share their electron. So it looks like this. They form a covalent bond to make a hydrogen molecule. Okay, so we have our two atoms of hydrogen here. What will happen to them two is they will covalently bond to form H2, and then therefore they will escape into the atmosphere, and it will leave magnesium sulfate, which will be our magnesium ion that we've drawn here and here. So we'll leave our magnesium ion and obviously our sulfate ion as well. They've bonded, ionically bonded, to form magnesium sulfate. Okay, so really, really important to get your head around the idea that the magnesium has lost 2 electrons, it's been oxidized, and it has given these electrons 1 each to the hydrogen atoms, which have been reduced. It's gone through a reduction. So we can call this a redox reaction because there has been reduction, so the hydrogen ions have been reduced, and there has been oxidation, i.e. the metal, the magnesium, has been oxidized. So we can call it a redox reaction. So there really is a lot in this video to get your head around, so do have a go at answering these questions and we'll run through the answers at the end. Okay, so let's go through the answers. Number 1, will calcium displace hydrogen from sulfuric acid? The answer really is yes, okay, and that is because calcium is more reactive than hydrogen. So write a word equation for this reaction. So it's going to be calcium plus sulfuric acid is then going to produce our calcium sulfate, and that is of course because calcium is more reactive than hydrogen, so it's displaced hydrogen plus hydrogen, and that is our word reaction. Write a symbol equation for this reaction. I'm going to do this down here. So calcium, Ca, plus our sulfuric acid, H2SO4, is going to make calcium sulfate, so SO4, plus hydrogen. What is oxidized and what is reduced in this reaction? Okay, so calcium as the metal is oxidized and hydrogen is going to be reduced. Remember, oxidation is the loss of electrons, so calcium is going to lose electrons and hydrogen is going to gain those electrons, so that's going to be a reduction. So write the ionic equation for this. So it's going to be calcium, which is the calcium atom. We can add that to obviously our sulfuric acid, which is going to contain our H plus ions and our sulfate ions, but our sulfate ions are going to be spectator ions, so we do not have to include them in our ionic equation. So we're going to have 2 plus ions. It's then going to form calcium ions and the hydrogen atoms. Okay, so really in our ionic equation, calcium Ca plus 2H plus forms Ca2 plus H2. And then we can write the half equations for these. So the half equation for calcium is going to be calcium is going to form calcium 2 plus ion and plus 2 electrons. It's going to lose the 2 electrons. And hydrogen is going to be, it's originally 2 H plus ions. We're going to add 2 electrons that come from the calcium, and therefore it's going to make H2. So there is the answer to those questions, and as I said, it's quite a difficult video to get your head around. So if you have understood that, you can move on to a quiz and exam questions to really start testing yourself. And if there's anything you do need help with, or you didn't understand any part of that, then please do get into contact with one of our tutors who'll be happy to help.